Whenever you are differentiating functions like exponential functions with a number base, okay, like for example, let me just do some examples over here. Let's say that you have y equals 2x. I'm sorry, not 2x, but 2 to the x power. Y equals, let's say, 5 to the x power. You can have some base that are like decimals too, something like 0.1.05 to the x power. You see what I'm talking about, right? Like you have a number base, like, I don't know, I can't be too creative anymore, like half. But if you work with functions like this and you're trying to find the derivative, we are using this theorem, this formula right here. Okay, and I'll show you a couple examples in this video. So the derivative of the first function, 2 to the x, will be natural log of 2 times e to the x. Okay, it's always going to be natural log of that base times that original function. Okay, so if you look at the second one, where we had y equals 5 to the x, the derivative will be natural log of what? Natural log of 5 times that exact original function. Okay, that's really what it is. All right, let's try this one. If you want to find the derivative of 1.05 to the x power, you need to write down what first? Natural log of 1.05, and you're multiplying this by that original function. Okay? Doesn't matter what the base is, same rule applies. So let me do this last one. The derivative is going to be natural log of what? 1/2 times that original function. Okay? So if I come up with the general rule over here, if you have y equals some number a to the x power, its derivative is going to be natural log of a times that original function. Okay, so that is theorem A, or this nameless theorem that we are using for these 4 problems. So let me show you how to do these 4 problems, okay? So first one, I think we did this one already. If y equals 2 to the x power, then y prime equals, write down natural log of 2 first, and you're multiplying this by that original e to the x, okay? I think this theorem, they drew parentheses around natural log of 2. That's okay. I'll do that too, and I'll get rid of this multiplication dot. I'm just trying to copy the same format. All right. How about this one? Well, we have to start by writing natural log of what number? No, I don't want to draw parentheses around it. I want to write down natural log of 1.4. And I will say that I'm multiplying this by the original function, 1.4 to the x power. Okay? All right, let's do 2 more. Well, these 2 have a number in front, but don't worry. We're just going to find the derivative of 5 to the x and 3 to the x and put that 5 in front of it. Okay, so nothing special. So y prime equals, just keep that 5 the same for right now. Okay, don't do anything to this 5. It's just waiting. Okay, now what are we multiplying this by? We need to write natural log of 3 first, right? Natural log of that base. And you multiply this by that original 3 to the x power. And that's it for this. Okay, so just like one liner, right? All right, last one. Y prime equals, what's that number in front? This 3, I just have to write it down, 3 times. But now let's go handle this 2 to the x power. I need natural log of 2 multiplied by that original e to the x power. So that's it for these 4 basic examples on page 107.